Okay, for today, we did classwork at the beginning after we'd gone over our homework of sequence, series, and variations. Then these are four problems from the released SOL that we're using as a package to prepare that students should do. And at this point, they are already assigned these, and I am going to go over these four problems. So what is the sum of this infinite series? Remember that we can only add up an infinite series if it's geometric and if either the terms are getting smaller or the absolute value of R, the common ratio, is less than 1, which those two mean the same thing anyways. But when you're looking at it as written out as a series of numbers being added up, you just have to verify that it looks like the terms are getting smaller. And of course it has to be geometric, because this wouldn't work if it was arithmetic. Right? On your formula sheet, you have a formula which looks like S infinity equals A1 over 1 minus R. So it is true these terms are getting smaller, so we can add these up. This infinite series will converge to a sum. We just need to plug in for two numbers, A1 and R. And the A1 is easy, that's the first term. That goes there. Remember, the R is the ratio of consecutive terms, meaning divide the second by the first, or the third by the second, or the fourth by the third. It doesn't matter, they're always going to be the same thing. I'm going to do R is 60 over 100. And I can simplify that. That is 0.6. So if I plug that in, 100 divided by 1 minus 0.6. I mean, that's easily put into the calculator. Now, you could also just put 60 over 100 for R. As long as you put it in parentheses, everything would work fine. But, I mean, at this point, it shouldn't be an issue about how to calculate it. I will finish calculating it, right? That's 100 over 0.4, which is 1,000 over 4, just multiplying top and bottom by 10 to get rid of the decimal. And 1,000 divided by 4 is 250. So there's the first. Second, what is the 14th term of an arithmetic sequence with a first term of 7 and a common difference of 10? We have a formula on our formula sheet, which you should know. You should know to go to it. It looks like this. This is for any term in an arithmetic sequence, can be given by a formula, which we can figure out by using that. Right? We need to plug in for two things in that formula. A1, the first term, and D, the common difference. And those are given to us directly, right? There's the A1, and the common difference is that. So AN equals 7 plus n minus 1 times 10. And since we're looking for the 14th term, that means that is the n. So plug in n equals 14. A14 equals 7 plus 13 minus 1. Sorry, that should have been 14 minus 1. I'm getting ahead of myself. minus 1 times 10. So A14 equals 7 plus 13 times 10, which is 137. Okay, this is a variations problem. The amount of work done when lifting an object varies jointly with the mass of the object, m, and the distance the object is lifted, d. Which equation models this relationship? Okay, so what does it mean to be a joint variation? And joint variation we know to be a direct variation with a product. If you look at our choices here, right, the first one looks like a inverse variation with a product, right, because the m and the d are in the denominator, so it's not that. The next one looks like it's a direct variation with m and an inverse variation with d, so that's not it. And I'm going to jump ahead to d. D looks like a direct variation with d and an inverse variation with m, so that's not it. And again, the joint variation is when it's a direct variation, meaning everything's in the numerator here with a product. So W and MD, and the K is the constant of variation. So this is the right answer. Okay, y varies inversely as the square root of x. What is the constant of proportionality if y is 16 when x equals 4? So we've generally solved these problems in 3 parts. First, they tell you the kind of variation. Next, they give you a data point so that you can solve for the constant. And next, you answer some kind of a question. This one's not asking us to answer a question at the end. It's only asking us to find the constant. So we still need to do the first couple parts. We need to set up a variation that looks like y varies inversely as the square root of x. Y varies is the k, and since it's inverse, that means that it goes in the denominator, the square root of x. That's the variation. Again, second part would be they've got to give you a data point so you can solve for k. And here's the data point, right? Y is 16 when x is 4. 16 equals k divided by the square root of 4. 16 equals k divided by 2. K equals 2 times 16, which is 32. And I think those were our 4 classworks. Let me make sure. 2, 3, 4. That was all the classwork. And the lesson for today, I'm just going to go over a few more problems. There's 3 questions that deal with normal distributions and permutation combinations. So remember what a normal distribution is. A normal distribution means it's a distribution of data, and distributions of data can be graphed in many different ways, right? A histogram is one way to do it, right? In a histogram, the heights of each rectangle is telling you the amount of data in each column. On this axis, there's going to be some kind of measured data, right? And if it was a normal distribution, what you would expect is your data has a peak in the middle, and then it falls away symmetrically to each side. This is not a normal distribution, right? It has 2 peaks. It has a peak here, it has a peak here. Okay, normal distribution has 1 peak. In statistics, you would call it unimodal, and it would be symmetric with respect to that peak. So a normal distribution would normally look more like this. It would have the tallest column in the middle. It would have lesser columns to either side. And it could be approximated by placing a curve over the top of it, which is generally known as, well, it's the normal curve, but it's also known as a bell curve because the shape of this curved line is like a bell. Now, if you want to describe a normal distribution, if you want to quantify a normal distribution, you need 2 values. You need to know the mean, which is the peak, right? It's the data value, which is right in the middle. And you need to know the standard deviation. And the standard deviation is a representation of how spread out the data is. And literally, standard deviation means it's some kind of average of how far apart the data is spread, deviation. What we know in a normal distribution is if you go about halfway down the bell, you should be about 1 standard deviation away from the mean. And standard deviation has got a symbol which is a Greek letter sigma, right? It's a lowercase sigma. So this is +1 to the right. That's kind of hard to see. Let me erase that. Right? This is about, let me change this. Right, there's the mean. There is 1 standard deviation to the right. And of course, it would be about the same distance to the left. It'd be 1 standard deviation. So this +1 sigma. This is -1 sigma. And I could go farther. I could go, if I go about the exact same distance to the right of that, that would be +2. And this would be +3. This would be -2. And this would be -3. And in this case, if you notice, we're dealing with the heights of a large population of ostriches, meaning how tall are these ostriches, right? If I graphed all of their heights, right, putting an X for every ostrich that was in this value range, let's say, then I would actually know what a mean is and a standard deviation. They didn't actually give us any values here. We don't know what the mean height is. We don't know what the standard deviation is, right? It doesn't, the question is asking us what % of the data would be in between this -3 deviations to the left to +3 deviations to the right. Well, if you don't have data to enter into it, then the mean is 0. And the standard deviation is 1. So you could do this using a table of what we call z-scores, because every one of these is actually called a z-score. But for the most part, we're going to use our calculator to calculate these percentages. Right? What we know is that the area underneath this curve, the whole entire bell curve, is 1. So when we find the area in between any 2 particular values, we're going to find a percentage of how much is in between those 2 values. And in your calculator, you're going to go here, second, quit, clear, second, and you go to the vars. Right? What does it say above the vars? It says DISTR for distribution. And you notice the first 2 are normal PDF and normal CDF. Right? We never use 1 normal PDF. We only use 2. 2 calculates the area underneath the curve. So when I hit 2, okay, on your screen, yours doesn't look like that. This emulator, which is on my computer, doesn't show the same thing yours does. Yours looks like this. Lower, upper, mean, standard deviation. Okay, in this problem, since we are being asked within 3 standard deviations, that means our lower is -3. Our upper is +3. Our mean is 0, and our standard deviation is 1. So you can enter all that in the TI-84, at least when you're in class, or if you're using the Wabbit EMU, you might be able to use that too. I can't, but what I can do, what your calculator is actually already doing for you, is I can just enter them inside the parentheses here, separated by commas. So this is -3, -3, comma, 3, comma, 0, comma, and 1, and parentheses. Right? And when I hit enter, I'm going to get the % of the data which is in between -3 and +3 standard deviations. Okay, that is 0.997, which means as a percent, 99.7. which is there. So the answer to this question is 99.7. Now, we should also understand, remember, or know how to figure it out, that there's a standard percentage also between -2 and 2. Right? How could you figure that one out? Well, you could just change these -3s to -2 to 2. What percent of the data on any normal curve is in between -2 standard deviations to the left and +2 to the right? Okay, so I'm going to bring this up again, second, enter, and I'm going to just, in place of my -3 and 3, I'm going to put 2 and 2. -2, there we go, 2 and 2. And now I get 0.95. So 95% of the data in a normal distribution is in between -2 standard deviations to the left and +2 to the right. Okay, which leaves what percent of the data is in between -1 and +1 standard deviations. So let's try that one too. So back to the calculator. Second, enter. You can enter it yourself. One and 1. So the percent of the data which is in between is 0.68, which is 68%. And in fact, those three percentages are called the empirical rule in statistics. It's 68%, 95%, and 99.7%. That's called the empirical rule. This is ±1. This is ±2 standard deviations. This is ±3. In the statistics book that I taught out of, I think they call it the 68, 95, 99.7 rule. So, in whatever, that's how normal distributions work, and we use them to calculate the probabilities for normally distributed data, which are actually quite common. I mean, we wouldn't be studying this if this wasn't something that actually popped up a lot. Okay, next, which of these four situations represents what's called a combination? Combination as opposed to permutation, right? So in terms of, how do we tell which one is a combination and which one is a permutation? Combination versus permutation. Right, a combination is written as NCR. A permutation is written as NPR. Right? A combination, you're choosing R things from a group of N things. So N is a bigger number than R. In a permutation, you're choosing R things from a group of N things. The difference is, when you're choosing a permutation, order is important. It's like saying, how many ways can 10 runners finish first, second, and third in a race? Order is important, because if 3 runners finish first, second, and third, if those same 3 runners finish third, second, and first, that's a different solution. Order matters. In a race like that, order matters. In a combination, order doesn't matter. Right? So this is the one that order matters. Well, if you read these 4 here, in B, C, and D, you're choosing, you have a number of people and you are rearranging these people, right? Determining how many different seating charts can be made, placing 7 people around a table. I mean, the only thing that's changing is the order you're putting people in. Determining how many different ways 8 runners can be assigned to lanes on a track. I mean, there's 8 runners and they're filling 8 lanes. What's going to change in between all these different possibilities? Their order. That's all you're looking at. which is not a great example of a permutation, but it is a permutation. I mean, in this, the letter B, this is like saying, sorry, that was incorrect again. That's like saying you're from a group of 7, you're filling 7 positions. Okay, there will be more than one way to put 7 people in 7 positions. Right? The second one, it's 8 runners, so that would be from a group of 8, you're filling 8 positions. Even the last one that says determine how many different 6-letter passwords can be made using the letters in the word pencil. Well, there's only 6 letters in pencil, and you're choosing a 6-letter password. So all you're going to do is be rearranging the order of the letters in pencil. So that would be a 6P6. Actually, when we learned about that, we learned that these 3, all 3 of them, that's really where we use the factorial. And the factorial goes by, if I do this one here, right, 7 factorial, and that means 7 times 6 times 5 times 4 times 3 times 2 times 1. That's the other way that you can calculate it. You're just trying to rearrange a set of things. That's how you figure out how many there is. I mean, in the end, whether you calculate it using a factorial or you calculate it using a p, you're going to get the same value. And that leaves us with the only one of these 4, which is actually a combination, is letter A. And if you read it, determining how many different groups of 3 employees can be chosen from 10, there's nothing in that would tell you that it matters which of the 3 was chosen first, second, or third, or that they're going into positions that are different from each other. It's just a group of 3 from 10. And that is done by doing 10C3. So the only one that is a combination is the first one. The other 3 are permutations because order matters. And they could be calculated either using the NPR or by using a factorial. Now, all 3 of those, combinations, permutations, factorials, are found in the calculator, in the math, and then you go to the PRB, which is right here. And there they are, 2, 3, and 4. So, I mean, we weren't asked to find actually how many different groups of 3 employees can be chosen from a group of 10. But if we were to be asked that, then we would enter it in the calculator like this. First, you enter the 10. Then you go math, PRB, and you hit 3 for NCR, and then you enter the 3. So the calculator is assigning 10 to the N and 3 to the R. And when you enter that, you get 120. All right, that's equal to 120. Now again, the question didn't ask for that, but I'm just using the question as a way of reviewing the concepts that we used here. Now let's just show, just for fun, that whether you use 7 factorial or 7p7, it actually is going to give you the same thing. So first I'm going to do the 7 factorial. Kind of running out of space there. 7, math, PRB, 4. Enter. 5,040. Okay, now let me try 7p7. First I enter the 7, then I go to the math menu, pick math PRB 2 for NPR, and since I'm putting 7, I'm choosing 7 or rearranging 7 people into 7 positions, then it's 7p7, and I hit enter, and I get 5,040, right? Those are the same thing. Whether you envision these last 3 as being permutations or factorials does not really matter. Now the next one, the last one, is clearly just a permutation. It says the number of permutations of 8 objects taken 3 at a time. I mean, that is unambiguous 8p3. You know, you don't even have to ask yourself, is order important? They told you it was a permutation. Right. Now, I should say that there is a way to calculate this without using your calculator. You have that on your formula sheet too. NPR equals n factorial over n minus r factorial. So in this problem here, 8p3, that would be 8 factorial over 8 minus 3 factorial, which is 8 factorial divided by 5 factorial. And we didn't do a lot of work simplifying factorials like this. I mean, at this point, you could enter that into your calculator too. 8 factorial divided by 5 factorial. But generally, the way you would simplify is you would say 8 times 7 times 6 times 5 factorial. So you peel off the first few factors, 8 times 7 times 6, and you let 5 factorial represent everything from 5 on down to 1. In the denominator, you have a 5 factorial. And now you can cancel the 5 factorials, which means all that's left is 8 times 7 times 6, which is 6 times 56. 6 times 50 is 300. 6 times 6 is 36, so that's 336, which is here. But again, you're not likely to do that, even with this formula on the formula sheet, because you have a calculator that does it for you. And even I would use the calculator if I had to. Right, so let me do 8p3. 8 math PRB 2 and enter a 3. And I get 336. So the main thing to remember about combinations of permutations, order matters for permutations. It does not matter for combinations. Right, the homework assigned was a package which I will send out in the email. I will post to the website with the answer key, actually. For fifth block, you had a fair amount of time to work on this in class. Eighth block, less, but it doesn't matter. You still do what you can to solve it. We'll go over it next class. So we will have a quiz next class. And I haven't not exactly sure, but my guess is we're going to do sequence, series, variations, and combinations, permutations, normal. There'll be something in there probably from those 4. So that'll be the quiz for next class. And that is it.